Hello everyone, I'm Bob Hagan with Club SciKidz, and today we are going to look at our box called Save Our Oceans. Oceans are extremely important to us. We're going to talk about some of the physical characteristics of the ocean and how man has impacted the ocean environment, specifically plastics. We're going to talk a lot about plastics. So join us for another Camp in a Box. So, welcome back. I've got our Save Our Oceans activity guide, and of course our Save Our Oceans box here with all of our materials and activities. And if you open up your activity guide, you will see that in the introduction it talks about the Great Pacific Garbage Patch. Now this is a large, very large area in the Pacific Ocean that is nothing but a floating mass of marine debris and plastic. And scientists have been trying to figure out, number one, how to reduce the amount of plastic that gets into the ocean. That's the most important thing. And number two is how we can collect the trash that is in the ocean. A lot of it does end up on our shorelines, it washes up, but still there's a lot that is floating out there. More importantly, plastics do break down to a certain extent. Ultraviolet light from the sun breaks it down into very small microparticles, and the fish that we eat actually consume, since it is their environment, consume the plastics that are in the water. And of course, if that is happening, that means that when we eat the fish, that we are also consuming the plastic. And what kind of effect is that having on our health? Okay, so we have two main activities in this experiments in this box. The first one is making bioplastic, where we can use vegetable products to make a plastic as opposed to the way plastic is normally made, like in this test tube here. This is a synthetic material that is petroleum based. We're going to make some plastic using corn oil and cornstarch. We also have a packing peanut test experiment where we use these regular packing peanuts, which I don't like at all, because when you open up a box they get everywhere and they get static electricity on them, so they stick. Okay, and we'll also then look at an alternative, and these are packing peanuts that are made these are packing peanuts that are made from starch, and they break down. They're biodegradable. They don't stick around for 400 years. And these are the type of products that we should be using. Then we're going to talk about the ocean zones, three of the major ocean zones, and you're going to make a model of the ocean zones, and we actually have glass bottles to make that with. If you do have a glue gun, I would go ahead and collect that in your lab for this box. And having a glue gun is really a good idea for our boxes. It makes things go faster, and really for any craft. You can get a glue gun with some glue sticks for less than $6 at Walmart. maybe even better than that at the dollar store. So try to have a glue gun in your lab. Equipment wise, you are going to have a beaker, a plastic beaker, and also a 35 millimeter syringe, no needle. And we're going to use this to demonstrate Boyle's law. Robert Boyle was a physicist and a chemist, and it's going to be all about pressure. And obviously when you're dealing with the ocean and the water, pressure is an important concept. So let's get started. I'm going to put my activity guide here to the side, all right, and open up to the first one, and that is making bioplastic. So what I'll do is I'll take out my equipment here, and in your bag we have cornstarch, we have some corn oil, corn syrup, and we have some red food coloring, okay? And in this bag here is you have a 50 milliliter beaker, which you can use over and over again, and this can become part of your lab. So what we'll do is we'll take the, look at the first ingredient here. The one thing that you'll notice is that science experiments are a lot like making something, a recipe in the kitchen, okay? You just follow it step by step. Now sometimes it doesn't work out, but that's okay because you can do it again. Sometimes when you're baking or you're making some kind of food dish in the kitchen, it doesn't work out. It might take a little bit of practice. That's okay. All right, so what we'll do is we'll put a tablespoon of the cornstarch. Let me open this up. And again, having a set of measuring cups, a set of measuring spoons in your science lab is really a good idea. So I'll take 1 tablespoon. Okay, let's put this over here so it doesn't spill. And I'll put it in the bag that everything came in. Okay. I'm going to add 20 milliliters of water. So the beaker is graduated. That means it has marks where certain measurements are. So I'm going to have, look at this, and I'm going to measure out 20 milliliters, which is not a whole lot. Okay. And I'll put that in the bag. It says to add 2 drops of corn oil. Let me stand this up here. So let me open up my corn oil. Two drops of corn oil, okay. Half a tablespoon of corn syrup. And measuring spoons here. Here's my corn syrup. Corn syrup, you'll see it in a bottle at the grocery store. It says Cairo syrup. That's the most famous brand. And corn syrup is obviously comes from corn and is a sugar that is derived from the corn, used in a lot of foods as a sweetener. And there's a lot of calories in corn syrup, so you should probably limit that in the number of foods you eat with corn syrup. And I'll put that in the bag. And just let that kind of drip in there. And I'll put that to the side here. Okay, close the bag. So let me see, make sure I have everything. You can, review it and go over. So I've got the corn oil, I've got the water, I've got the corn syrup. Okay, see, I forgot the food coloring. So let's add a couple drops of this red food coloring. The good thing about our boxes is that there's lots of material, so you can do this experiment many times. You can vary it, and you should vary it. You should change, that's what's called a variable. Change one thing at a time in an experiment and see what effect it has on what you're doing, okay? only one thing at a time, because if you do more than one thing, you don't know which one that you changed or which variable that you changed. Okay, I did it again. I dropped in the plastic part. Let me fish that out. Okay, this is the bottom ring of the top of the plastic cap. Okay, couple drops, 1, 2. Okay, close the bag. Let me put the cap on so I don't spill it. Remember, food coloring, you don't want to get food coloring on you, okay? It stains, it's hard to get off. You don't want to get it on your clothes. When it combines with other things, then that's okay, because it's combining with that material. Let's say it's flour or sugar or whatever you're making. The food coloring will combine with the molecules of the food and will be less likely to stain your hands or your clothes. But you know, when you're doing these experiments, there's nothing wrong with having a pair of gloves on. So I have this, close the bag, squeeze until all of the materials are thoroughly mixed up. Okay. And then it says microwave the bag for 20 seconds. So we'll be right back. Okay, so we're back, and I have microwaved my bioplastic materials. Now this is hot, so I'm going to sit it to the side, and I'm also going to let it kind of for 2 or 3 minutes come together, and we'll see what it brings. Okay, so let me collect my materials here and push them out of the way. It's a good idea to kind of clean up after each activity just to keep organized. Okay. All right, so there's also some information here about the pros and cons of bioplastic, and the next activity is the packing peanut test. Okay, so packing peanuts, put this in here, are used all the time, and not as much as they used to be. We have sort of these big bubble packets that are used. We use them all the time when we ship boxes out. And in your container here, you have, in your plastic bag, you have 4 cups. Okay. So 4 souffle cups. Again, you can easily get these in any grocery stores. They are great to have in the lab. We have a pipette, which comes in the bag. All right, and we have 4 different colors of what are the starch packing peanuts, and 2 of the regular that you normally see used in packing. Okay, they're white. Okay, so we've got some water here, and we'll need some salt, which I have here off to the side. So let's see what it says. Okay. So what they want you to do is they want you to label each one of the, as just like it shows in the picture here, 2 cups that say fresh, 2 cups that say salt water, so, or say salt, okay? So the first thing I'll do is I will fill up the cups with some water, about halfway or 3/4. Okay. Just assume I've marked 2 cups that say fresh and 2 that say salt. Of course, representing fresh water and salt water. All right. Then I'm going to take some salt here. Okay, and pour a little bit in my hand here. It actually says a teaspoon, so we'll estimate that. But as a good scientist, you should use a measuring and just kind of split it up. And you're making some salt water. Okay, maybe a little bit more. Okay. All right. Again, coffee stick. Let's make up our salt water. I believe we're trying to simulate the ocean. Okay. This is going to stay fresh over here. And then what we do is we put these in here. So I'm going to take these the old-fashioned packing peanuts. These do not break down very easily. They stick around for probably hundreds of years. And that's why we try not to use them anymore. So I will put one in the fresh water. Okay, kind of dunk it, it floats. Put one in the salt water, all right? And then I have these packing peanuts. Now there's 4 of them, and these are made of starch, okay? A starch is part of one of the food groups. It could be corn, a vegetable, it could be potato, it could be pasta, like from wheat. Those are starches. And the good thing about these are that they break down. They are biodegradable. So they will disappear within a short amount of time. The other thing you can do, so let me put, before I get to that, let me put these in here like this, okay? Now, whatever experiment you're doing, you should have your lab notebook out, okay? And you should be drawing pictures and making notes. What does it look like? I've even had people show me where they've taken pictures and they've cut the pictures out and printed off the pictures, put them in the lab notebook so you could see the results. And so what you want to do is you want to observe. Observe means you're watching. You're watching to see what happens, okay? What is the difference between the old-fashioned white styrofoam packing peanut and the one that is biodegradable or made of starch? Another thing you can do, which will not hurt you, is you can actually put one of these in your mouth, okay? Or at least one of the ends. And you can see where it starts disintegrating, okay? And you can eat it. It won't hurt you, all right? So I'll bite it for yourself. Chew it. And I can feel it just disintegrating in my mouth. And that's what we want with biodegradable products. That's what we want to, if something is going to end up in our ocean, we want it to be able to disintegrate and disappear over time, to break down. But when it breaks down, not to harm the water or the ocean life, okay? Usually when things need to break down, they have to have ultraviolet light from the sun. So if something is going to sink and we want it to be biodegradable, that's not good, because sinking in the ocean means that it's not going to have the exposure to the ultraviolet lights, which is a wavelength of the white light that you see from the sun. So this breaks down to nothing, and you can pick this up in your hand and you can actually feel it's all kind of mushy now, all right? It is breaking down very easily just by putting it in the water, all right? Now, the question is, let me get a paper towel. The question is, do these starch peanuts and the other peanuts, which environment do they break down best? Fresh water or the salt water? There's a million different variations of this experiment. Remember, you're only going to change one thing at a time. Is there any effect if we do this outside? Natural light as opposed to light like in my workshop here. So just experiment with it, and remember the word variable, okay? Variable means you're going to change one thing in an experiment. Maybe it's going to be, is it inside or outside? Does it have light or is it in darkness? What other liquids could you put these in? What if you put these in vinegar? What if you put them in orange juice? Okay, just try different things like that. So we'll put these to the side. We'll see how those go. Okay, now the next activity is kind of cool. It's the Ocean Light Zone activity. So in your box, you have, pull this open, you have 3 glass, and they're glass, so be careful. Put this to the side. Jars. These are spice jars. They have flat sides. And we have some sea life in here, plastic sea life, which we're going to need. We have green food coloring. We have blue food coloring. I think we're going to also need this red food coloring. Okay. Back to the side. So I'll get my jars open, take off the lids, make some space here. Remember, clean as you go. All right, now we also have some labels that you can put on the jars, all right? And it's Sunlight Zone, Twilight Zone, and Midnight Zone. So the first thing I'm gonna do is I'm gonna fill the jars. Okay, fill them all the way up to the, where you see the threaded part. Or higher, it doesn't matter. Understanding the levels of the zones, the zone levels of the ocean is important because each zone has different life in it, okay? Different species of fish and crustaceans. And you should know those. You should be able to know an example of where, say, a crustacean like a crab or lobster would be, or where is mahi-mahi in what ocean zone is that in, or dolphin. What organisms are at the lowest level of the ocean, and why are they at that lower level? And being at that lower level, how does it affect the way that they behave or the way that they look? These are important things. Okay, so what we're going to do is we're going to put a, let's get our blue food coloring first. So the first zone here, for the sunlight zone, we're going to just put one drop of food coloring, okay? And for the twilight zone, you will need 2 drops. Again, be careful not to get, these are pretty good squeeze bottles, not to get it all over you. And then for the midnight zone, we're going to add 5 drops of blue. You can tell this is going to be on the bottom because it's a lot, we're making it a lot darker. 2 drops of green. And 1 drop of red. Okay. Then once again, I'm going to take my coffee stirrer of science. We're going to make the sunlight zone here. We're going to make the twilight zone there. And we're going to make the midnight zone here. Okay. All right. Put these back in my cup. All right, and then we can put the different organisms in fish and all that in the zones here. So we put this little starfish, not starfish, stingray, sorry. We got a walrus here. Okay, got an octopus, we'll put him down here. All right, shark, maybe this one here. This looks like a fish, maybe, this sort of a dolphin or actually killer whale, so we'll put him here. Okay, now to help you decide where to put the fish and the crustaceans, we have this chart in your box, okay? So use this, read about it, learn about all the different, the depths of the zones and how much light there is, all kinds of good stuff, all right? Light zones of our oceans. Put the lids on. Oh. Slippery. Put the lids on. Nice and tight. So, and then we do is we put them together. Okay. And we use a hot glue gun. So the midnight zone will be on the bottom. Twilight zone, and see how I'm altering the direction of the bottles, all right? And I can also use these labels. I'm not going to put them on right now. I'll just leave that for you. And to keep it together, then I use a glue gun, okay? again, can't overemphasize the importance of having a glue gun in your science lab. So what I'll do is I'll put some glue on here. Actually, I'm not putting the glue on here, but I'm just demonstrating, okay? And like that. And there you have the ocean zones, okay? Midnight zone, midnight zone here, twilight zone, and the sunlight zone. There's lots of stuff to read, again, about the garbage patch. You won't believe how big it is and what a problem it is. There's a young boy in here who, at the age of 14, set a Guinness Book of World Records in launching 2-liter bottles, which is done a lot in schools. And but he was on vacation one time and he discovered that there was just trash everywhere. And he did some research and came up with some possible solutions for cleaning up the oceans. And I'll let you read about that. And he's still working on this. He's just still a very young man. So look at that. Now, Boyle's law, after an Irish chemist and physicist, Robert Boyle, states that when a gas is at a consistent temperature, the pressure and volume are oppositely proportional. So what does that mean? So what I have is my big syringe, 35 millimeter syringe, and I have some mini marshmallows. And to demonstrate this, I'm going to put the marshmallow in here like this and put the syringe back together, okay? And I'm going to put my finger over the tip. Now there's no needle here, so over the tip of it, and I'm going to try to push down and see what effect it has on the marshmallow. Then what I'm going to do is I'm going to pull out, okay? So let's try that again. Look how big the my fingers are in the way. Look how big the marshmallow gets, okay? It just expands. And basically this demonstrates Boyle's law. So experiment with that. It's very simple. You just put the marshmallow in there. You can put 2 marshmallows in there. You have a whole bag of marshmallows to experiment with. Of course, if you start eating them, there'll be less experiments, okay? All right, so lots of cool stuff in here too. Secret formulas, this is one of my favorites. I'm gonna leave this to you at home. It's making mermaid bark. Okay, so we have ocean stuff, gotta have a mermaid. Of course, mermaids are not real. Science is real, mermaids are not real. All right, but that's really delicious. Also, mini aquarium, you can build one of those. All right. And it has the 20 micro experiments and observations. These are additional extended experiments that you can do that are related to all of these other activities and experiments that you've been doing in here, okay? Science riddles, you can quote me different quotes in science, like from Jacques Cousteau, who invented the aqua lung, which is what scuba divers use. The world of science fiction, Dr. Seuss, and the Lorax, okay, which he wrote a book about deforestation, all right, and how that was affecting the planet. Boyan Slot is the young man that I was talking about who was trying to figure out how to get the Great Pacific Plastic Patch or island or whatever you want to call it out of the ocean. He's tried a few things, hasn't been successful, but like any scientist, you want to try over and over and over again, okay? So I wanted to show you what my bioplastic looks like. I'll take it out of the bag. It still feels pretty warm. And as you can see, it has become a solid. And this is the basis for a bioplastic that might be used for different things. And the thing to do is to experiment and try different materials, plant materials, different types of oils. But here's my bioplastic. So I hope you've enjoyed this box. Remember, science is real. Have a lot of fun, and we'll see you next time.